In this lesson, we will be using trig functions or relationships to evaluate trig functions of acute angles. The first thing we want to remember is the 6 basic trigonometric functions. So we have sine, cosine, and tangent, and then their inverses, which are cosecant, secant, and cotangent. What we do want to remember now is how to find these relationships. We have theta. Theta is a Greek letter that represents one of the acute angles. So here's our theta, and then we want to remember the relationships of the sides of the right triangle as compared to the angle of theta. So the side that is adjacent to theta, and then the side opposite of theta, and then the side which is directly across from the 90-degree angle, which is the hypotenuse. So as we remember what these ratios or relationships are, we're going to start with sine. So when we start with sine, we remember that sine is opposite over hypotenuse. So the sine of theta, we find the opposite side, and we divide that or compare that to the hypotenuse of the right triangle. Cosine is the adjacent side compared to the hypotenuse. Tangent of theta is the opposite side as compared to the adjacent side. The cosecant, secant, and cotangent are simply the reciprocals or inverses of sine, cosine, and tangent. So cosecant is the inverse of sine, and that is the hypotenuse divided by the opposite side or compared to the opposite side. Secant is the hypotenuse as compared to the adjacent side. And then cotangent is the adjacent side as compared to the opposite side. Remember that these are the reciprocals or the inverse. So we can also define cosecant as being the 1 over the sine of theta. That secant is 1 over the cosine of theta, and cotangent is actually 1 over the tangent of theta, which are the reciprocals of the original 3 trig functions. So we use these ratios to find the sine or cosine tangent, or cosecant, secant, or cotangent of theta. In this example, we would like to evaluate the 6 trig functions of the angle theta, shown in this right triangle, using the measurements of 13 for the hypotenuse, and as compared to theta, 5 will be the measurement of the adjacent side, and 12 will be the measurement of the opposite side as compared to theta. Now, when I first learned trig functions, I learned a little word that helped me, which was called SOHCAHTOA, and that gave me that the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. And then we know that the cosecant is the inverse of sine, secant is the inverse of cosine, and cotangent is simply the inverse of tangent. So when we're looking for the sine of theta, we want, here's our theta right here, and we want the opposite over the hypotenuse. So that's simply going to be the relationship or ratio of 12 to 13. And we know that cosecant is the inverse of that, so that will be 13 to 12. Then the cosine is the adjacent over the hypotenuse, which would be then 5 to 13, and the secant is simply the inverse of that, so that would be 13 compared to 5. The tangent of theta is the opposite over the adjacent, so that is going to be 12 over 5, and the cotangent is the inverse of that, and that would be 5 over 12. let's take a look at our next example. So here we have our theta. 5 is going to be the side that's adjacent to theta, and 10 is going to be the side that's opposite. But what we're missing is the hypotenuse. One simple way to find the hypotenuse is simply to use the Pythagorean theorem, since we are dealing with a right triangle. So remember that the Pythagorean theorem, a squared plus b squared is equal to c squared, where c is the measurement of the hypotenuse and the a and the b are the measurements of the legs of the right triangle. So we can use 5 squared plus 10 squared is equal to c squared. So we have 25 plus 100 is equal to c squared. So we have 125 is equal to c squared. And when we take the square root of both sides, the square root of 125 simplifies to 25 times 5, which means that that's going to be 5 square roots of 5. So our hypotenuse is 5 square root of 5. And now we can use that to find our trig functions, to find our relationships. So the sine of theta is the opposite over the hypotenuse. So we have 10 over 5 square roots of 5. Now we can't leave that in this form because there is a square root in the denominator. So there's a couple of things we can do first. If you wish, we could simplify. 5 goes into here 2 times and 5 goes into here once. So we have 2 over the square root of 5. Now before I simplify this, I'm actually going to take the inverse to find the cosecant, and that way I have the square root of 5 over 2, so there isn't a root in the denominator, and we don't have to simplify that one any further. Now coming back to the sine function, we need to multiply both the top and the bottom by the square root of 5, which is rationalizing the denominator. So that gives us 2 times the square root of 5 over the square root of 25, which is 5. And remember that we cannot simplify the radical and the number that is in the denominator because they are not the same. Now if we take a look at cosine, remember that that is going to be opposite cosine, adjacent, over the hypotenuse. So we have 5 over 5 square roots of 5. Now to simplify that, we actually have 1 over the square root of 5. I'm going to stop there for 1 second to do the secant, which is the inverse of our cosine, which is the square root of 5 over 1, which is simply the square root of 5. Now I'm going to come back and I'm going to simplify this by rationalizing the denominator. So I'm going to multiply both the numerator and the denominator by the square root of 5. And that gives me the square root of 5 over 5 as my cosine. Now doing the tangent is opposite over adjacent. That's going to be 10 over 5, which is 2. And then the cotangent would be the inverse or reciprocal, so that's 1 over 2. The next thing that we will need to remember is our special right triangles. The first one is the 45-45 right triangle. And if you recall, our most basic 45-45 right triangle has measurements of sides 1 and 1. And remembering that if we use the Pythagorean theorem to find the hypotenuse, we find out that the hypotenuse has a measurement of the square root of 2. So using these and using one of the 45-degree angles as our theta, we can find the relationships for sine, cosine, and tangent of our 45-45 right triangle. So to do that, remember that we would have 1 over the square root of 2 as the sine. And when we simplify that by multiplying both the top and the bottom by the square root of 2 for sine, we actually come up with the relationship as the square root of 2 over 2 for the sine. That's also going to be our cosine. And then our tangent is going to be 1 over 1, which is 1. So when we take a look at our 30, 60, 90 right triangle, we remember that the short leg, which is opposite of the 30-degree angle, is 1. Our hypotenuse is 2, and the longer leg opposite the 60-degree angle is the square root of 3. So when we use those relationships to find sine, cosine, and tangent, first of all, of our 30-degree angle, which we use as our theta, we have 1 over 2 for our sine. Cosine is the square root of 3 over 2. And tangent is going to be 1 over the square root of 3. But we do want to simplify that by rationalizing the denominator, so we're going to multiply both the top and the bottom by the square root of 3. So that's going to be the square root of 3 over 3 as the tangent of 30 degrees. Now if we want to take a look at our 60-degree angle and use that as our theta, to find the sine, we want opposite over hypotenuse, so we have the square root of 3 over 2. Cosine, which is 1 over 2. And then our tangent is the square root of 3 over 1, which is simply the square root of 3. Now, instead of memorizing this table, because then you can also put in the cosecant, secant, and cotangent simply by taking the inverse of the sine, cosine, and tangent, it might be easier to first of all remember the special right triangles, and then remember your trig functions. That way, you don't have to memorize the table for the special right triangles, but you could easily figure them out by simply quickly making a sketch of the 45-45 right and the measurements of the sides in the most basic form, as well as the 30-60-90, remembering the measurements of the sides in the basic form, and then simply remembering your trig functions of sine, cosine, and tangent. And that way you don't have to memorize the table. In our next example, we want to find all the missing lengths and the angle measurements of the right triangle. So first of all, if you recall that a triangle has a sum of angles of 180 degrees, since we already have one angle that is a right angle of 90 degrees, we know that the sum of the measurements of the other two must be 90 degrees. And so if we take 90 minus 62, we know that this angle has a measurement of 28 degrees. Then we can use our trig functions to find the measurements of the other two sides, side B and side C. The first thing that I want to make sure that you understand is that your calculator must be in degree mode before we begin. So would you please check by going to your mode and make sure your calculator is in degree mode. Then when we set up our trig functions, what we want to make sure is that we're using things that are given to us or known. So we will use the 62 degrees, even though subtracting we know that this angle is 28. We'll use what's given to us, and also the measurement of this side, which is 6. So the first thing that we could do is we could find the tangent of 62 degrees by finding the opposite, which is side B, divided by or compared to the adjacent, which is 6. So what we want to do is we want to solve for B. So we are actually going to multiply both sides by 6. So we have 6 times the tangent of 62 degrees, and that's going to give us our measurement for B. And so now you just need to use your calculator. So if you take 6 and then times tangent and press 62 and then press equals, you should come up with a measurement for side B of 11.28, rounding to the nearest hundredths. Next, we could do the cosine of 62 degrees. So if we do the cosine of 62 degrees, which again is using our measurement of 6 and then finding the hypotenuse, we would take the adjacent side, which is 6, divided by the hypotenuse. So what we would do is simply multiply both sides by c and then divide by cosine of 62 in order to get the c by itself. So we have c equaling 6 divided by the cosine of 62 degrees. So using your calculator, we can find that the measurement for side C is 12.78, rounding to the nearest hundredths. In our next example, we want to show you how we can use trig functions in real-life applications. So, if you measure a flagpole and you are standing 20 feet from the base of the pole, so here we are, I am standing 20 feet from the base of the flagpole. The angle of elevation from the point on the ground to the top of the flagpole is 65 degrees. Here's my right angle. My flag flying. Find the height of the pole. So I want to know how tall is the pole. So if I use my 65 degrees and my measurement of 20 feet, I can use the tangent of 65 degrees by taking my opposite over my adjacent side. When I multiply both sides by 20, I can take 20 times the tangent of 65 degrees to find my missing length, which is the height of the flagpole. And using my calculator, I would find out that my flagpole rounding to the nearest hundredth is 42.89 feet. In review, here are the ratios of the 6 trig functions. Please remember the special right triangles, and please remember to complete the reflection.